All right, so let's get started. So looking at our do-now today, we were talking about what you guys did yesterday, which was taking the hydrochloric acid and the sodium hydroxide into a beaker. You used some universal indicator, and I wanted you guys to get the reaction to be neutral. I will answer this question because I know it's a rather tricky question. So it was really important that before we make any assumptions on amount of this versus amount of that, we get it neutral beforehand. If it's not neutral, the ratios won't be the same. So let me write down that equation and talk about that in a little bit more depth. So in that reaction, what you were doing is you were adding hydrochloric acid to sodium hydroxide. When it neutralized, it would form sodium chloride and it would form water. So that is what that equation looked like. HCl is my acid. NaOH is my base. And this bit over here, this was neutral. So that was kind of my green color that we were looking at. We're okay with that so far? All right, so what I can do with quantitative analysis, and this is what we're going to be looking at for this topic, is that if I know the concentration of one thing, say for example my hydrochloric acid, I call that my known, and I can use that to figure out an unknown. Any of these things in my equation could be my unknown. What I can then do is, if my reaction is neutral and I have it balanced, I can then assume that the acid concentration and the base concentration are the same because we have a neutral solution. If I don't have a neutral solution and I have too much acid, we saw that with the universal indicator being red, and what that means is that I have more acid than base. So I won't be able to use that as a reference point to figure out what the concentration of the base is because the acid is way over proportioned. Same thing happens in the reverse. If I had too much base, my solution was blue, and so again, it wasn't a balancing act. It wasn't balanced. I had way more base than I had acid, so when I go to do the calculation, it won't work. So it needs to be neutral in order for this to work, because the only situation that the solutions are going to be neutral is if my acid and my base equal each other, and if my acid and base equal each other, then I can use it for my calculations. So this is the idea of what we're talking about when it comes to titration. So before we jump more into concentration and titration, I just want to point out the assessment requirements so you guys are mindful of how this will break down. On your yellow piece of paper, this is on the back side. So for this titration assessment, it is a practical-based assessment, so really, really tricky in a sense of absences. So it's really important that you guys are in class, so that way you don't fall behind, and also so you have practice with the equipment, and it's going to be a long kind of assessment that we're doing. So that's the first thing to keep in mind. Second thing is that I will assess it in different sections, so that way it's a little bit easier and you guys don't have to remember everything all at once. So I've broken up the assessment. Just like with some of the other marking schedules, your grade is more or less determined on the lowest section for the titration assessment. So each section will be marked at achievement or excellence. Some of them do overlap a bit, but keep that in mind when it comes to that assessment, that you need to perform well on all sections. The good news is there is some forgiveness in some areas where you can make a mistake and you can then use a different area to show evidence of understanding. Are you okay with that so far? All right. The first part is part A, and that's the one where you are making your titration instructions. You're basically starting to write a method for titration, explaining how this experiment works. So again, achieve, merit, and excellence. I'll talk about part A in more detail, what we're looking at for each level, but that's the first section. Part A is a practical-based section for this internal. So keep in mind that you guys are going to have to use equipment and things like that. Next one is part B and C. Part B and C are very, very similar in a sense that they are both calculation-based sections. They both are analyzing data. The difference between part B and part C is that part B, I give you the data, and part C, you guys collect the data yourselves. You're going to collect the data through titration, which we'll start looking at today with the equipment. Keep in mind that there is some forgiveness allowed in this section. So if you make a mistake on your calculations, I can still give you a merit because you get basically a second chance at it in part C. So do kind of keep that in mind when you're looking at that. Again, I will talk about the calculations later. I don't want to overwhelm you with everything. I just want you guys to know where we're going with this. So that's what part B and C look like. Like I said, part B, I give you the numbers. Part C, you have to find the numbers yourself through practical work. So B will just be a written test. And then the last thing is part D. Part D is a written section. This is, again, like another shot to kind of show your understanding if you make a mistake in part A, which is really good. It's a nice little backup. And what you're basically doing in part D is reflecting on your experimental procedure. So you're looking at part A, you're asking yourself, did you actually make a good method in part A? And the other thing you'll be thinking about is the concentration that you have calculated for the unknown. Is it the same or is it different from what the manufacturer has claimed? If it is different, then explaining why the manufacturer might have it wrong. So again, we'll talk about that in more detail when we get to D, but do keep in mind that's what we're looking at. So it's a big kind of assessment. It is worth 4 credits, but I will assess it in smaller chunks so that way you guys don't have to remember everything all at once. Sound good? All right. So I just want to show you now some of the things that we've talked, or that I've briefly talked about. How'd you guys find trying to pipette into a beaker and getting it green? Was that easy or hard? That was relatively kind of hard. What you guys are actually going to be doing instead, so it's a really inaccurate way to be going like, put some drops there, put some drops there, go back and forth and keep adding drops until you get neutral. That is not a very scientifically accurate way to do this sort of calculation of unknowns. So what we're going to be using is something called the titration equipment. And what you're going to be doing is the exact same thing. You're going to have acid and base. You're going to mix those two things together. You will have an indicator to help you indicate when it's hit that neutral zone. And you will be able to figure out volume and concentration to figure out amount of acid used and amount of base used. So this is what the titration equipment looks like. And then you guys will be doing some calculations to figure out the concentration of unknowns. So that is what you guys will be using in class, and this is what can be used in a scientific lab to figure out concentration. This actually is a cheaper, kind of old school way of figuring out concentration. Nowadays, what scientists use are things like HPLC machines, which is high pressured liquid chromatography machines. That is what I use for my master's, so this is actually an area that I have a lot of experience in. It's slightly different in a sense of, instead of using acid and base to figure out concentration, I actually took my substance and I tested it at different concentrations to get a standard curve, and then I used my unknowns in reference to that standard curve. So it's like when you have, you guys did this last year when you were doing the roll the ball experiment, the physics investigation, and how you got a linear line for your trend, and then you can use that linear line and that y equals equation to figure out unknowns. So same sort of idea that we actually do in the real lab. So I just wanted to point it out to kind of see how the skill sets you're learning now kind of adapt and change when you're actually in a lab, proper lab setting. But it's a very common question that we ask because we are mindful that, you know, everything's toxic. It is just a matter of the dose. We good? All right. So let's talk about what we're going to do today. So I want to give you guys a chance to tinker with the titration equipment. I will start by passing out page 12, so you guys can have a look at it. And I will grab some of the equipment and talk about what you're going to do. So there's 2 different bits of equipment I want you guys to tinker with today. We're just going to tinker with water, so all very safe. We don't even need goggles or anything like that. There's the burette and there's the pipette. And you're going to do slightly different things with the burette and pipette, but I'm going to grab them first so you guys know what they look like. Cool. All right, let's pause this. You guys can have a look at this while you wait. Cool. All right, so the first thing I want to talk about is the burette and how to read it correctly. I'm going to just grab one of these guys here so we can get used to seeing it. I'm just trying to grab one that has a numbering label. All right. So, something to kind of keep a note with burettes. They're a really good way for us to control the amount of volume that's going into a flask or into a beaker. But we have to keep in mind that the top of the burette is labeled as 0, and the bottom of the burette is labeled at 50. So it's a 50 ml burette. Quite different from a measuring cylinder. So we grab a measuring cylinder for comparison. So measuring cylinders, on the other hand, their 0 value is at the bottom, whereas their top value, so in this case this is a 100 ml measuring cylinder, is at the top. So do kind of keep that in mind. That changes how you will read it, because you're reading in this case from the top down because of the direction of where the 0 is. In this case you're reading from bottom up. So just keep in mind that all the training you guys have done for
sorry, man. I just wonder if you
you gotta go to the dentist and eat as well. Alright, so we're just going to be mindful that we're reading things in a bit of a reverse. Really important that you are aware of that, so that way you don't accidentally misread your burette, because it's going to cause all these problems when it comes to your calculations. So I will do the first couple depending on how confident you guys are feeling when it comes to the reading and if you need more examples. Anyway, the top here is where the 0 is, the bottom is where the 50 is. So where I'm looking at here, we are reading at the bottom of the meniscus, which is that there. So make sure you're reading from the top down, not the bottom up. So when I'm looking at this, I start with 7. And then each little line represents 0.1. So 7.1, 7.2, 7.3. Now, depending on if that bottom of the meniscus touches the line or is in between two lines, we can use different numbers. If it touches the line, then I'll end it with a 0. So we should always have 2 decimal places for all of our burette reading. If it looks like it's in between 2 lines, then end it in a 5. So that way it states that it's kind of halfway between those 2. So do keep that in mind. Remember, like I said, you're reading from the top down. Don't read from the bottom up. So if you were looking at a measuring cylinder, you might go, oh, that's 8.567. You can go 8.7, and that's not right. Do you want me to write that down as the wrong answer, just so you know? Okay. So wrong would be 8.70, because that's reading from the top. Sorry, reading from the bottom. You'd be surprised how many people make that mistake, and that mistake will probably just mark you down to an achieve because it'll really throw out all your numbers. So don't make that mistake. Would you guys like to see another one? Okay. So this, do you want to see anyone in particular, or do you want me just to do the next one? They're more or less all the same, actually. All right, so this one here, when I'm reading it, I can see it's gone past the 3 mark. Again, we're looking at the bottom of the meniscus. If you guys want, you can grab rulers to help you kind of check it. When you're actually using the burettes, I would suggest putting a white piece of paper behind it, because that makes it a little bit easier to see the back of the meniscus. But since we're dealing with a piece of paper right now, do that. And I see that it is on the 2nd line after the 0.3. So I'd read that as 3.20 milliliters. Are we good so far? All right. I'm going to leave it for there because I want you guys to have a chance to work on it, and I also want to give you guys a chance with the equipment. I just wanted to explain how to read that burette because you guys are going to be reading that burette. All right, cool. So let's talk equipment. I might actually just move this so we can see me. Sorry about the vertigo. All right, and I'll put this back on the board so we can talk about it. Okay, so there are 2 different things that I would like you guys to try today with the equipment. The first one is the burette, and the second one is the pipette. This guy here is my burette. It's, like I said, my long glass tube. that I can measure volume with. Now, obviously, you're not going to just hold it like crazy. There's a way to kind of plant stand it up. So, what we're going to do is over here with shelf number 10, we have what we call plant stands. You guys are going to need to grab one of these guys. And you will be able to secure your burette to that. So I'm going to grab out my burette here. Put it into my little plant stand. I might need to open it up so it can go through. There we go. Close that up. Okay. You okay? What do we need? Good? So that's what that looks like. That's how it'll be held up. You guys will just be working with water today. So first thing before you even start playing with the burette, you want to make sure you guys know how to read it to complete the rest of question 1. Then set up your burette, and you'll see on the bottom of page 12, there is a little practical there to measure initial and final volume of 20 drops of water. So you guys can practice reading the burette and also calculating the difference and then figuring out what the volume of 1 drop is, which is really cool. Keep in mind, record it at the beginning and record at the end. I highly suggest taking a white piece of paper, holding it behind so that way it's a little bit easier to see the meniscus. And have a little play with trying just to turn it on so you can see how it works. With this, I do have beakers for you to collect water. We need to use distilled water. So distilled water is very specialized water that it has removed all the ions from it. Really important because I don't want the little ions to then crystallize in my burette and then clog it. So that's why we use a special type of water. We don't use the tap water for this. So you can collect some distilled water. You can pour it through the top. I can get you some funnels to make it a lot easier. And then you can either drip it into a beaker or you can drip it into a flask. Not two flasks, whichever you want to do. But that's what the burette kind of play is. The second thing that you guys are going to be testing out are our pipettes, which are these glass bits here. The pipettes have a set volume to them. I have a different variety of them, so some are 20, some are 10, there might be a 25 in that lot, I can grab you some more. It's good to kind of just test the different ones because I could give you any one on the assessment. And the way the pipettes work is that they only measure that specific amount of liquid, and it measures it very, very accurately. What you want to do is get the water up to the line there, and that line up there is going to be the 20 mils. In order to get the water up, what you're going to be using is a bulb. You have several different choices of bulbs, so that's why I want you guys to play with it so you can figure out what bulb you like. This one's personally my favorite. You just stick it on top, get the air out, and suck up the water. So that's my personal favorite. What I do is I normally suck the water past the line, and then I quickly remove this and use my thumb as the seal, and then I move the water down to the line. So again, you guys will figure out what you like. There's other options too, like this bulb here that does like a suck and escape. Some people really like this one because this one actually holds the volume of the liquid, whereas this can go up and down quite a bit, which is why I normally pull it off and use my thumb. The last one that people might like are these little rolly ones. So the rolling pulls the water up. The problem I find is that sometimes you don't get enough volume with that one pull, so you kind of have to like pull it off, hit yourself, put it back on, roll again. So you got to figure out which one you like, and I want you guys to have a chance to kind of just play with it. In that case, what I want you guys to do with the water is put the water in a beaker, so that way you can suck it up from there, and then practice transferring it into a flask, because that's what we're going to be transferring it into for the titration. If you want to double check if your pipetting is accurate, there's two different things you can do. The first thing you can do is get a measuring cylinder and just check if it's at the 20 mil mark or the 10 mil mark. The other option, and the one that is more accurate, is to actually use this scale. 1 milliliter of water is equal to 1 gram. So if you pipette out 20 mils, you should have 20 grams of water. So that's just a way, that's something you can do if you want to double check to see how your pipetting skills are going. Accuracy and precision is going to be really important for this assessment. It's one of the things we do look at. Cool. So those are the two things. I'm happy if you want to start with the burette or start with the pipette. It's honestly up to you. Everything is just water. It's just you guys get used to things. Cool. And I'll come around and help as you guys go. All right. Time is yours. Have a tinker.